Good afternoon, ladies and gentlemen. Hello from beautiful Amsterdam. I'm Ansgar Grunseid. Today we are going to take a journey together into the solar system, and not just to any planet, but everyone's favorite planet, and soon to be the world's most favorite planet, Saturn. So what we're going to discuss today in this talk is a new effort to build the world's best CDN we call Saturn. And it's not just any kind of CDN, it's a Web3 CDN. And what we're going to go through is we're going to talk about what a CDN is, why they exist, and where there is this momentous opportunity to redesign and rebuild what a CDN is using all the new primitives and tech that we have that Web3 brings. So with that, please, if any of you guys have any questions, please jump in as we jump into this together. So, what is a CDN? CDN stands for a Content Delivery Network. And if you look on the left diagram, let's look at what the world looks like without a CDN. When you open your browser, your desktop browser, your mobile browser, or any device and load a website or access any server online, your device, your browser, connects with a server somewhere else out on the internet. And this is generally like a point-to-point connection. So let's go through an example. Let's say you load an image on Instagram. In the model of the world without a content delivery network, you as a user and your phone would connect with an Instagram server somewhere else in the world. And this is likely going to be one place. And what happens is now as we scale Instagram from 1 user to 10 users to 10 million users to 100 million users and 1 billion users and beyond, if we have one kind of centralized location where all the images and all the Instagram data exist, it becomes inundated. And these servers will literally melt under load. And this comes in, or where this comes in, is the birth of the CDN. So the very first CDN, the progenitor of CDNs, was Akamai, built by a bunch of MIT grads in the early 2000s. And the problem they set out to solve is how do you scale a service like Instagram, where if you have 1 billion users all around the world and they're all trying to access the same content, they can't all hit the same services, or the same servers. Those servers can't scale. It's imagine like you, if you're the server, trying to hold a conversation with one person, that's doable, 2 or 3 people, that's doable. All of a sudden, you're trying to hold a conversation with 1 billion people, you can't do it. Same thing with a server. They can't scale that much. So the problem that Akamai and other early CDNs set out to solve is what can we distribute in scale to power a website? So when you access a website, that website is comprised of many things. It's comprised of text, it's comprised of images, video, elements like that. And the biggest and heaviest images and assets are actually retrieved in the same manner by everybody. So if you go to Instagram and you link someone an Instagram post, they're going to see the same picture that you see. And that same data is going to flow to them as it flowed to you. And so Akamai and these CDNs realized this, and they said, wait a second, what if we can take that image that everyone is loading and distribute it globally? So instead of that one image being stored on the one Instagram server, what if we copy it and we place it all over the world in thousands of servers close to end users? And then when I load the Instagram page, I will load that image from a server close to me. And when someone else in India or Chile loads that image, they'll load the same image, but from a much closer copy and a server closer to them. And that is really the whole idea of a CDN, is you take what's static and you distribute it and scale it globally such that the original servers don't melt and you can grow the service to a larger degree than previously possible. And the key piece here is you improve performance. The closer an end user is to the server they retrieve content, the faster and cheaper it is to retrieve. So that's the genesis story of the very first CDNs. They came about to help scale web services as they grew quickly and improve the performance thereof. Now, this brings us to the present day. What the hell is a Web3 CDN? There are lots of Web2 CDNs. Ones you may have heard of might include the original Akamai still around or Cloudflare. And now we have an opportunity to build a Web3 CDN. What a Web3 CDN entails is it's a CDN, just like the prior generation CDN, where you take caches of content and you push it close to end users for performance and scalability. But you take and push that content close to end users using Web3 primitives and crypto incentives. And as we're going to explore in this talk, With these primitives, these unlock new and larger networks. The network we're talking about, Saturn, has the potential to be the largest distribution network of content in human history. And we're going to get there, and we're going to get through why. Now, why are we starting to build this? Where do we see this opportunity? Well, there's a huge opportunity with Filecoin's network specifically, where Filecoin has assembled a massive storage network of 16 exabytes and rising, but it's really locked. If you store data in Filecoin, it's not easy to retrieve. It's more like this Facebook model where it's all stored on a few centralized servers. What we can do with the retrieval market, and Saturn specifically, is take all the data that's stored in Filecoin and distribute it globally so that it's fast and cheap to access everywhere. And most importantly, we can do this and take advantage of market dynamics, where all CDNs, that existed prior, Web2 CDNs, they grow as like a centrally managed organism grows. Somebody in a boardroom, in a business room, wearing a suit somewhere, gets out their checkbook and says, we need to build another data center here, and they go and build that data center. That's a completely old-fashioned and different model than the model we're bringing with Web3, where it's more like a dynamic market, a marketplace, where there's supply and demand, where the market can see there's an opportunity for new servers to be added, let's say in Mumbai, and that market opportunity is recognized by someone who has servers in Mumbai, and they can connect them and join the greater network. And there was no central coordination here. No one had to ask a company, do I have permission to plug my servers in and make Saturn a better network? They just did it, and they rewarded in kind. So how are we going to go about building this? Let's zoom back in now. So we kind of covered what a CDN is and some of the Web3 primitives we're going to use to build Saturn. How are we going to go building it? Well, one of the key pieces here is when you don't have a central organization running everything and you allow anyone to jump in, you need to build trustless, permissionless systems. And this is a key piece, because if anyone can plug their servers in, that server operator in Mumbai plugs his servers in, who's to say that either through malice or incompetence, he's going to screw something up? You request cat.ping, your favorite kitty picture, and you get back dog.ping, someone else's favorite dog picture. We need to forfend against that kind of attack or network failure. And the other key piece here is the scalability of a decentralized network. So again, with all the Web2 CDNs, there is one company and one brain, or one set of brains, thinking about how and where their network should grow. We want to race past that. We want to change the game here, where in a decentralized manner, anyone can see these opportunities and plug in. And there's some other key tenets here. All of our work is open source and will be open source. Anyone can jump in, anyone can work on it, and we welcome that, and the whole network can improve. And the last piece here is, why should you participate? And the answer is, you can be rewarded. If you have spare capacity, you can add that to the network and reap the rewards. You can improve other people's experience online and make the internet faster and receive rewards in turn. And that's a completely different model than every other CDN that's been built. Now, let's jump into some of the technical pieces here of how we're building Saturn. So as I mentioned before, one of the key facets of Saturn is that it's trustless, which means anyone can plug their infrastructure into the network and start serving requests to end users and making their experience faster. But you run into this problem of, again, what happens if you request your favorite kitty picture and you get back your favorite dog picture? Well, we lean into content addressing with SIDS here to solve this problem. And how does this work? When you request a file, you don't actually request cat.ping. You request the content ID or the SID of that file. And the SID of that file contains the hash or unique ID of that file. And then what the server responds to you with is not actually just the raw bytes of the file, but it's what's known as a car file, which is a package of that file along with a bunch of hashes of all the data therein, in a manner where the end user can verify that content, that it's the content it requested as it's being received. So what we call this is incremental verification. And this means, let's say you start watching a YouTube video, and the YouTube video is 2 minutes long. As you start watching that YouTube video, and some person, you have no idea who it is, and their servers are sending you that YouTube video, you know the content ID of that YouTube video, and you know how to verify that YouTube video as you receive it. So as they send it to you, you're incrementally verifying that every frame as is rendered in your browser is the right frame, and not necessarily like a random dog picture as one of the frames. And this is fundamentally new. There are no CDNs that do this. Every CDN you use currently, you have to trust the other party to send you the information you request. So building this incremental verification with car files and content addressing lets us achieve a trustless network. The other piece that we want to achieve with Saturn is to build an inclusive network where anyone can plug in all manner of hardware to the network and receive rewards. So if you own a bunch of large capacity servers that have tons and tons of hard drive space, you can become a large cache for other users on the network. If you plug in a smaller server connected to much faster bandwidth, you could be an endpoint that many users connect to and you serve as like a hot cache for those users. Or if you're just on your local desktop machine, you could install a Saturn desktop app and bring your storage to the network when you're online in a manner that you want and you're fully in control over, and you also receive rewards. And in the future, we would love to unite browsers together too. So even without having to install anything, you could contribute to the network and receive content from the network in a peer-to-peer, browser peer-to-peer manner. And the reason we want to do this is imagine Airbnb. One of the reasons that Airbnb has been so successful is they didn't just focus on large mansions, they didn't focus on beachside resorts. They let the world add all this capacity from small houses and all the way up to full-scale castles and connected them with an audience, customers that want to stay in those locations. And we want to do the same with hardware that you can connect to Saturn. So you can connect anything you have and supply the capacity, and the network will figure out how best to leverage that capacity and in turn how best for you to be rewarded for adding that capacity. And the last piece here is the crypto incentives. And this is the engine upon which Saturn will burn bright, where, again, going back to the prior example of Web2 CDNs, where they're centrally managed, what's different here when Saturn is decentralized and you plug in capacity to the network, you can join the network and earn Filecoin. And it's part of a supply and demand network. So if you kind of see this graph here on the left, this is actually from Helium's website, which I recommend everyone go to. It's absolutely fantastic. You can see a network map of Helium if you're familiar with Helium. But imagine the network kind of looks like this. This is something we'll build and we'll have readily available too, where you can see where there might be a lot of user requests flowing through the internet, and there's not a bunch of points of presence, a Saturn points of presence or network capacity in a given location. And imagine there is like the best Christmas present you've ever opened is just waiting for you to open it, and all you have to do is plug in some servers in that location and reap the rewards. And so in this manner, there's this dynamic supply and demand where the network scales itself. And again, as far as scaling and scaling speed, because it's permissionless, you don't need anyone's permission to add capacity. No one needs to sit there and say, yeah, you can add a server in Mumbai or you can't. You can add it to the network and get rewarded justly. So what we've covered so far is some of the high-level ideas of things that have changed and new technology we have to build a fundamentally different CDN. One that's trustless, where anyone can join the network and send content that's verifiable to end users. One that's permissionless, where you don't need anyone's permission to add your capacity to the network. One where you receive rewards no matter the device you have and no matter the capacity you have when you add it to the network. And this open source software that will tie it all together, and the crypto incentives that unite everyone into the same boat. So at a high level, that's what we want to accomplish with Saturn, is we want to build the world's largest distribution network in human history, the fastest and the cheapest, and that's how we're going to do it, is using these tech primitives. So if anyone has any questions, I have answers.
I can start us off.
Sure, Patrick.
From your experience building Arc and then starting off building Saturn, what would be your takeaways in building something which is essentially much more, there's much more power in the hands of the user and anyone can join the network? What are the sort of things you've learned from Arc which will come to Saturn?
That's a great question. The biggest takeaway, the biggest lesson learned is one of scalability, which is that when you don't have to have some sort of centrally planned or centrally managed team that decides how and where the network grows, the network can grow much, much faster. And so we saw this with Arc, a giant browser peer-to-peer network. We were able to scale from 0 to 100 million nodes in our network in a little over a year, which is unprecedented. And one of the reasons we were able to do that is because no one was sitting there deciding who and where to add capacity. Again, there's no one with the decision responsibility of getting out their checkbook and writing a check to build a data center somewhere. The owner of that data center, the existing infrastructure there, can, of their own volition, decide to join the network. So I'd say that's the biggest takeaway. One, simply of scale and speed.
I've got some questions which have come in from someone who's watching on the live stream. 1 second. You mentioned that there's these L1 and L2 nodes in the network. Do you have off the top of your head the hardware requirements or the system spec for these two different levels of the network?
Yeah, that's a wonderful question. So what are the hardware requirements, kind of minimal hardware requirements to plug in hardware capacity to the network? We want to run the full gamut and support everything from laptops and desktops, supplying mostly hard drive capacity or cache capacity to the network and kind of an L2, so not user-facing, where like a lot of end users won't be connecting to your desktop, but you might be an L2 cache layer to machines that are more user-facing. And so your hardware requirements for kind of an L2 cache machine would be your desktop, order of magnitude, hundreds of gigabytes to terabytes. And we also want to have other hardware, which is more user-facing, where you need much faster internet. Let's say like a gigabit per second connection, and anywhere from a few terabytes of cache attached, all the way up to a full rack of servers. So really anything in between.
Okay, great, thanks. And then another question is, I think that, I know there's a test network already, which has been spun up privately. When will the test network be readily available more widely, and when will people be able to join the network?
Another wonderful question. So right now, Saturn is in testing. It's not in production testing yet, but the tests are going splendiferously. And we don't have a specific time we can announce publicly yet of when you can get your hands around a Saturn node and download the software and run it on one of your servers or run it on one of your desktops. I'm afraid I don't have that yet. So keep your eyes out, and we'll be sure to let you know and be sure to announce the up-to-date timelines as we have them.
Great. And then the final question, which came in from the live stream, which I think I might answer, which is just when will the reward model or reward structure for Saturn miners be released? And we're having a crypto economic workshop after the live stream today, where we're going to be working on this further, and it'll be most likely in the second half of this year that we'll have something really concrete to share with people. Any other questions for Ansgar?
It's going to be a real question.
I'm ready for it, baby.
Yeah, so you mentioned, sorry, it's on. Yeah, incentives. So I would say, like, probably for a Web 2, the end user has really no incentive in terms of a CDN other than the service working, which is huge. In terms of Web 3, is that the same model, or are there incentives for Web 3 users around interacting with Saturn?
That's a great question. Two pieces, two answers. The first one is, in the future, we'd love to have the actual user become a part of the network and start sharing content back out. So in that model, which we're not at yet, but in that model, the user could also receive rewards for everything they share back with the network. So imagine kind of like BitTorrent or like Arc, where once you've downloaded a piece of content, you can begin seeding that and sharing that content out with others near you in the network. And in that model, when we cross that bridge, you will receive rewards for the sharing you've done with the network. That's one piece of it. The other piece of it is, imagine right now, when you access a website like YouTube, you don't pay anything in terms of like a monetary exchange. You don't open your wallet and pay YouTube 3 cents for every YouTube video you watch. YouTube monetizes you and then takes that money to pay for the CDN service. You as a user don't pay for the CDN. There is another model here where with Web3 and microtransactions, users could pay to download the content. So they themselves, the end user, pays. And in that manner, they could be incented and say, I will pay more for loading faster or more for better performance. And in that manner, they could be involved in this kind of the protocol talking with the CDN. So we're not there yet either.
Yeah, so because in that mode, it's almost as if it's a Saturn browser,
right,
as well, right? That the service runs through.
Exactly.
Right.
Exactly. Okay. Right. So those are two kind of different answers to your question of where things could go. But the very first version of Saturn will be built for what the market, how the market operates right now, which is websites like YouTube. They're the ones who are paying for content delivery. They're the ones buying CDN capacity, and the end users don't pay anything. So how that model will change in the future remains to be determined. But those are two potential ways it could, where the user would be part of the, either earning rewards or paying.
I covered it a little bit in the talk earlier, but already Brave has BAT, and BAT has individual users earning for the attention that they're giving to various websites. You could imagine hooking up BAT with automatic DeFi swaps to Filecoin and paying for the retrieval live. So a user is viewing a page with Brave. Part of the BAT that they would be receiving for viewing that page would then go to the CDN that is delivering the content, and that would happen automatically. I think this sort of thing can only work if it's completely transparent from the user, and the user is not involved in individual transactions, because from a product experience, no one's gonna like open a phone, try to load a page, and then like start paying for something. Like they have to be able to like receive the content right away. But if the browser does it for them automatically, then it could work. And so I think like thinking of integrating with things like Brave or pushing the BAT model to many other browsers, I think could be pretty successful.
There are also some web APIs coming along, like web monetization, which want to allow browsers to pay with microtransactions. So to help facilitate this kind of model and other models.
Yeah, I mean, imagining something even worse than GDPR for like clicking through on a website.
Yeah.
Because it's money.
Yeah.
Oh, it's a non-comment. Yeah, sorry.
Great question, though, Craig. Great question.
Great answer.
I have a question too. I feel like I think it's great. I think there's lots of promise with like Web3 CDNs, but I feel like after the presentation, I still don't have a very concrete grasp of what exactly Saturn is, and then how potentially differentiate from, let's say, like Miles or like the other, even like Titan. Could you share a bit more light on that, please?
Yeah, so I'm not sure so much about Titan. I'm not too knowledgeable about Titan and Titan's effort. As far as Mael, they'll be here in 2 days, and I don't want to put too many words in their mouth. But one of the differences is that Mael wants to pursue is they want to have end users paying. So initially for Saturn, again, who's buying CDN capacity is the service provider, like Instagram or YouTube. They're paying for CDN. And Mael's model is one of the kind of the half of the answer with Craig's great question, which is Mael wants the Web3 world or was building towards a world where the user ends up paying. And so it's the same kind of set of opportunities or changes where a user now has to kind of have a wallet and be able to pay for content. Yeah. Juan might be able to answer some of this better.
Yeah, I can give an answer to that as well. So in terms of how the value flows around, let's take the Web2 setup where content publishers, content providers, they pay cloud services to host files, host websites, and then accelerate content. And end users are essentially getting free retrievals. As we kind of spoke about in the break, it's not 100% free because there's this idea that then they'll purchase something from, if they're browsing a marketplace, they'll purchase something or they'll watch adverts. And there's sort of then a circular economic flow back to the content providers. However, when we try and map that in terms of like in-band payments, it gets quite complex, and the number of attack vectors that the system is going to have to counter for like just rises with every single different connection between these different nodes in the network. So what Mael focused in on, they said, okay, let's do what they called worse is better or less is more. And so let's just focus on that one interaction between a client and a provider. And let's try and make sure that that is as secure and as efficient, performant as possible. And whether it's a free retrieval or a paid retrieval, they're just focusing on that one interaction. And the idea being that if they get that interaction right, then you can start to see other things emerge around that, and people can build from that module into kind of more complex network-wide interactions. However, what that means is that you do have to kind of not have free retrievals for loads and loads of clients, because then you're subject to these Sybil attacks where you can spin up loads of different clients and try and make all these retrievals and then try and convince the content provider that you've done all this retrievals, and they then need to pay for it all. So it does put an onus on the client to have to then pay for a transaction or just govern the whole transaction in the local part of the network. So yeah, it's in that way, again, it's more Web3 focused. It's just between you and me if we want to do a transaction, and no one else is measuring it or governing it or kind of deciding what the payouts are based on it. It's just that the transaction happened and that's that done. And that's where I think Saturn is different, because the premise there is that people want to retrieve for free into their browsers in the same way they do in Web 2, and therefore there has to be this economic flow from content providers in the end, and therefore it kind of breaks the model that Mael going for of just focusing on that one transfer.
Yeah, I think that was a great summary. One thing I might add is the Mael pop structure might work between retrieval providers and themselves. So one, if you think back to the internet grapevine model, you could have a Mael pop that's very close to the users, paying for and retrieving data from another Mael pop that's further up in the grapevine to bring down data, and then eventually to a storage provider. So you could use the Mael pops as like really good links in that grapevine layer to have the individual kind of pairwise transaction be accounted economically. And so that you can kind of build up really well if you then figure out a way of getting Filecoin to the end users who are then paying for the content. And so there's probably a few approaches. One approach might be you can build products where you download and install a kind of a cache that makes your browsing go faster, and you might potentially pay for that. Or you can have the browser BAT model hook directly into Mael. And so you could have like BAT swapped for Filecoin and then going through the Mael network. I think in the Saturn case, it's the publisher will sign up to have some content accelerated. This maps closer to the traditional CDN model, where the content publisher is trying to accelerate some subset of content. They set up a relationship with Saturn. They pay Saturn. And then Saturn orchestrates the network to deliver that content quickly to the regions where that content is being retrieved from. And so it's two different adjacent tangential models that I think both can really work. There's probably other content models that are not yet explored well. I think we'll probably see a lot of experimentation across these, and over time we'll see kind of what happens in the inner parts of the network. My sense is that if we can have good interfaces, then all of these networks can interop and pay each other and so on. But I guess we're meant to figure out the interfaces there.
Great question.
Any more questions?
Yeah, I think part of what CX was getting at is like, hey, that was a good overview. It was kind of like what Patrick and I talked about. But I think there's no like concrete sense of Saturn itself. It may be useful to give an example demo of like how Arc works today and how browsers, and just talk through like load up an Arc page and then talk through like how browsers make those requests now, and that might help close some of the questions.
I worry going through Arc is the core of your question. Let me not rephrase it. Would you mind expounding a bit on what you'd like to see explained as far as Saturn's architecture would go? Diego's going to cover that some in the next talk and go into a bit into the kind of network diagram of like multiple levels of the cache. And
yeah, sure. We can wait for the next talk, and then like, I mean, what was getting at is like, oh yeah, I understand all the high level is pretty much similar across the board, and I want to understand like, oh, how like where's the current status of Saturn right now, and our roadmap, go to market, and all that kind of stuff. But if you're covering the next talk, that's fine too.
Oh, great. Yeah, so not all that will be covered in Diego's next talk. So let's see, some technical architecture of how Saturn currently works, and this is already built and running, is so in the browser, there's a new API called the service worker, which is like a JavaScript context that runs beneath the parent page. And it has a superpower. And the superpower of the service worker is it can see and handle requests made by the parent page. So the way Saturn is going to integrate and grow with websites is we'll have people install Saturn, or website operators install Saturn Service Worker. And then what happens is when a user goes to a website that's running Saturn, the web page will load and the service worker will begin running beneath the page, and it will see requests being made by the parent page, like for cat.ping or dog.jpg, and it will see content address requests, like requests for SIDs. And then that's when the service worker spins into action, and it sees those requests, and instead of sending them to, for example, the origin server, that kind of one server that the website's running on, it sends them to Saturn's network. And so it then sends a request to Saturn's network saying, please give me this content behind this SID as quickly as possible. And then what happens is that request is routed via DNS to kind of the nearest point of presence of the Saturn network. And that would likely be someone who's plugged in a bunch of servers and capacity near you in the network running Saturn software. This will generally be what's known as like an L1, or what we're referring to as L1, kind of layer 1 in the cache. So these will be machines that have likely running in a data center that have a lot of upload capacity, uplink capacity, and large cache capacity. So you'd be routed via DNS to one of these. And then one of these essentially does what a traditional CDN node or point of presence will do. It will look for that item, that SID, in its cache. And if it has it, it will return the car file of that file to you. So instead of, rather than like the plain text of the file, it will return the car file to you. And on cache miss, it will go to like an L2, or another layer in the cache. This could be some of the desktop nodes, or some servers that might not necessarily have as fast upload, but a lot of disk capacity, kind of a second layer in the cache. And onwards, that cache lookup will cascade all the way to the service providers, who again, kind of the nexus, if you remember Juan's model, where that's where the kind of the last stop where the data is absolutely stored. And then it kind of, as the cache cascades back, it's cached everywhere in kind of like LOU manner. And then finally the car file, either on cache hit or cache miss, is streamed back to the browser. And the service worker does another cool thing, which is that the incremental verification. So as this file is coming back, the browser knows the SID that was requested, and it gets the car file, and it can verify the content it's receiving from that L1 point of presence that it was connected to over DNS as it's being received, and to verify it. And then the service worker hands the plain text file, kind of like unwraps the car file and hands the data back and streams it back to the browser in the parent page. And then the browser in the parent page will render that content. So we've talked through a lot now in a little technical detail, but that's kind of a network flow, if you will. Is that kind of what you were looking for? Then there was another question, which is also an astute question, which is kind of what is the go-to-market strategy of Saturn? And the go-to-market strategy here is to find out like what hot request loads there are in the existing IPFS network. So like what is currently being requested the most from the IPFS gateway, and Saturn will serve those faster than the IPFS gateway. We are going to begin like racing the IPFS gateway. And once we achieve like the flip where we are now faster than the IPFS gateway, that's when kind of Saturn, the wheels come off, and we turn into the rocket ship. We want to grow and, be part of every website on the planet, let anyone around the world participate. But that's kind of the first strategy. So there's already all these requests flowing into the IPFS network. They're currently landing at the IPFS gateway, and they're not being served as well as they can be. And Saturn is going to be there to serve them better than they currently are. So that's kind of the first step. Does that help? Yes, thank you. Sagacious questions, thank you. Yeah.
All right, any more questions? Cool, in which case, it's on to Diego.